Hi, hello. This is going to be a quick one. A person or a character being regarded as an attractor point in Unreal Engine 5. Those of you who are familiar with parametric modeling and Grasshopper or Blender's geometry nodes already kind of know how this thing works or will work, but it seems to me that there are not many tutorials for Unreal Engine of how to create this kind of a relationship-based model. So we're going to make that. First step is to actually get rid of the test blueprint that I have done to showcase this and to create a empty blueprint class. So for that, in my content folder, I'll just create a new folder, call it Attractor point project or something like that. And inside of it, I'll just create a single blueprint class like that. It's going to be an actor blueprint. I'm going to call it a brick because first we will create the behavior for a single brick, a single entity, right? So the closer the character gets to the brick, it should enlarge, and also it should rotate into place, into being flat. So that is going to be the behavior of a brick, and then we will have a secondary blueprint that will populate this brick into a grid, right? At least that's the plan. All right, so let's double click on it. Open up this window, dock it right here, and first things first, we will just select the default scene root, click add, and add a cube. That is going to be our brick, right? Then we need some behavior. We need to define how it's going to behave. So in the event graph, we don't really need the event begin player character overlap, so I'm going to delete those. Actually, character overlap might be interesting because we can optimize it through there, but no. Simple tutorial, short tutorial. So we're only going to be using event tick. And for the event tick, on the event tick, we will be messing with this cube, with the size of this cube as well as the rotation of this cube. So we will be setting set relative rotation for the cube, just like that. And also set relative scale in 3D for the cube. There we go. We could just use set relative transform. Sure, if you want to do it that way, you can do it that way. Then for the rotation, we need to drag out of it and make rotator, basically separating the three inputs into X, Y, Z. And for the scale 3D, we need to make vector, also separating the inputs into X, Y, Z. So these are our rotations, these are our scale values. Now to actually get the proper values, I need to know where my character is and how far away this cube is from the character. So I'm going to say get player character, like that, and I will use is it get distance to? Yes, get distance to node for the player character, right? But 1 second, I'm thinking. So the target is the character. I should know this, but I will be printing just to see. Print string. And if we do it this way, it does not feel like this is going to work. So I'm going to print string and I'm going to see what kind of distance does it give me. So I'll compile, save. I'll drag the brick in here and I'll just have it centered around 0, 0, 0. And of course, we also need some geometry on which we can walk. So I'm just going to create a plane that's going to be at minus 10, and I'll just increase the scale for it to 200, or 100 is gonna be enough. Press play. Okay, so it's zeroing out. Okay, no matter where I walk, it's 0. Gotcha. Okay, so the distance too is not working. So instead of getting get player character and measuring the get distance to as a target, no, the target is self, and it's the other actor is going to be the player character. So it's measuring the from the player character towards itself. What's the distance? And now if we compile, save, and look at the look at the level, now we can see the distance change. Okay, great. That's what we want. So reconnect event tick. So now we have this. Oh, come on. Now we have this distance that we can mess around with to get the rotations as well as the vectors. And the easiest way to do that is with map range. Map range can be clamped, can be unclamped, doesn't really matter because we know, or actually it should be clamped, right? Because we want to cut off at a certain distance. Yeah, so map range clamped. And for now, let's just do make rotator, I guess. Apologies. And I'm going to say, okay, so the distances that we want to act upon are the smallest distance is like 2 meters, so 200, and the largest distance is around 5 meters. And everything lower than 200 should be always considered, you know, fully open in terms of the flipping of the tile, and everything that is more than 500 centimeters or units should be considered fully closed, so the tile is vertical and also scaled down. So in terms of the rotation, this should be 0 and this should be 90, like that. So 200 gets remapped to 0, 100 is 0, 500 is 90, so 350, yes, 350 is going to be 45 degrees, and so on. And then we just feed it into X for now. Also, let me go in here for the scale vector and just change these values to 1, 1, 1 so that we can actually see what the hell is going on. Click compile, click save, press play. And now technically if I move closer, yep, you can see that our cube rotates as it should. Okay, that's good. So now for the Z, let's make it 0.05. So that it's pretty thin. Compile, save. There we go. So now the tile is vertical and it flips to horizontal position as we get closer. Okay, that works. Then we want the tile to appear out of nowhere, right? So there needs to be another set of mapping involved. Actually, what happens if we connect like that? I think the rotation will be more interesting. Yeah, it flips like that in place now. Yeah, that's cooler. So let's have it connected to X and Y rotations. So now for the scale, I will use map range clamped. Again, Control C, Control V. The same values are going to be used, except that the output range, the closest output range, when we are very close to the tile, the scale should be 1. When we are far away from the tile, the scale should be 0. And I'll use that for X and Y inputs, right? So that it kind of shrinks when we are far away from it. Now I have no idea where the hell it is. So let's, oh, there it is. Just appears. There we go. right? Okay, so we have ourselves a working brick. That's it. That's all we need to do for one of these. I'll save, I'll close it. Now I will create another blueprint class, actor, and I'll call it array. Right, this is going to be our array blueprint. Open it up, dock it. And this array blueprint is going to, we don't really need anything in the viewport. We don't need anything in construction. We need an event to happen. So as we begin play, a bunch of these blueprints, a bunch of brick blueprints need to be arrayed in X and Y directions, right? In this case, it's going to be, you know, a boring example of just X and Y, but you can populate them any way you want. So for now, event begin play, we will create a loop, for loop, like that. And we will create another one. Within the loop, within each loop, we will create another loop. So you're creating a grid, right? You're creating rows, and then inside of each row, you're creating columns, or other way around. You're creating columns, and inside of each column, you're creating rows. So let's start with something simple like 10. 10 and 10 here. Later, we'll do this as a integer, as a variable, sorry. But for now, just static 10 by 10, so 100 tiles in total. And as it's looping through all of the, you know, X and Y coordinates of the loops, we want to spawn. Yes, we want us to spawn an actor from a specific class. Spawn actor, and the actor that should be spawned is going to be our brick. There it is, the brick. Okay, then it should spawn with a transform, so we'll make transform. Okay, and the rotation should be zeros, scale should be ones. We are not messing with those, but the location should be derived from the indexes, right? So this is going to be a little bit tricky, but I know that the size of the box of the cube that I'm using is 100 by 100 centimeters, right? It's 1 by 1 meter, because that's the default size of the box that Unreal Engine uses. So that means that for every step, the transform needs to increase by 100 centimeters, right? So whatever index we get in the columns needs to be multiplied. You know, 0 multiplied by 100 is 0, 1 multiplied by 100 is 1, 2 multiplied by 100 is 200, and so on. So we multiply it by 100 right here. That should work. And then this one also needs to be multiplied by 100. So we're basically, as we're counting which element it is, we're translating that to dimensions, right? So we're also counting the step size between the elements, right? The gap between the elements. That should work, so as this is done, we want to make the transform, but the transform needs to be make vector, because we want separate X and Y transforms for this. And technically we could just connect it like so and it should work. I don't see why it wouldn't. So compile, save, play. Hello? Oh yeah, actually adding the array into the game would be a nice idea. Play. Yeah, there it is. It just simply works. But there is a problem, and the problem is, well, right now I spawned right on top of the field, right? and my blueprint, my array blueprint is right here. I have selected it. You can see it from the outliner right here. If I move my array somewhere here and I press play, it still spawns exactly from 0, 0, 0 coordinate. That is because, let me reset that, and don't need the box anymore, or don't need the brick anymore. That is because the spawn transform is global, making this location a global location, so it doesn't matter where your blueprint is in the world, it's always going to spawn globally. So it's always going to spawn starting from 0, 0, 0. We kind of want to have flexibility in terms of where we spawn this. So I'm going to say, if I take the default scene root, you know, this, because this is an object, right? If I take this and I get world location, I do get this kind of placement of where it is in the world, and I basically can just kind of add all of this movement to the already existing world location. So we just plus sign, this is add, it's this, operators add. So I can add these up and use this as a vector instead, compile, save, play. Oh yeah, and now I actually need to move this away somewhere here, play, and now there's none of them, and now I need to find them. Oh no. Am I running in the yeah, there it is. Okay. Cute, isn't it? Okay, so that is done, which means that we can get rid of the background. We can take this array, I'll zero it out so that it actually starts from 0, 0, 0. Why not? And I will make a copy of it. Holding the Alt key, I made a copy at like 3 meters high. If I press play, that's pretty neat. We have a ceiling now. Bounce my head there. Let's make it big. Let's see how slow this gets. So for this X and Y, for these X and Y axes, I will just create a new variable right here. Call it size. Make it integer. Open the eye so that it can be changed from the settings menu right here. So the eye does that, and drag and drop it in. Get size, like that. Like that, like that. There we go. Now size is set up here. And also, while I'm at it, let me compile, select this, and where it says the default value, so make sure that you select the variable. Where it says default value, I'm going to start with something simple like 20. Compile, save. Okay, let's press play. Seems to be okay. We're running at like 50 frames per second, which is not great. That is probably because of all of the transforms that are happening and all of the measurements that needs to be taken. Also, I'm recording. But now with this done, we can select the array. And here we have our, you don't see it. There we go. Here on the left side, right side, we have, as the blueprint is selected, we have the setting. So I can just increase the size to 50 here, press play. And now it's technically 2000, yeah, 24 frames per second. Yeah, that's not gonna work. So we do need the top one to be not there while I'm recording. Of course, there are many ways of how you can optimize this, because right now we are measuring right into, we're measuring the distances to literally every element that there is. But yeah, you can always optimize. Maybe later I'll make a separate video. For now, we have reached the 20-minute mark, and that is it. These files will be available to Patreon supporters. If you want to support the channel, consider supporting the channel through Patreon. You get every single file that I make for this channel for free. Right. I'll see you in the next one. Later.